Okay, so SL 1.5 is logarithms. This may be a new word, but today we'll just introduce you to the idea of logarithms, and we'll go over it more in depth in 1.7, which will be in a coming video. So this is the expression for what log equals to. Now, logarithm has two components. When we write log, it will have a subscript and it will have a number after it. And it will be equal to some number over here as well. Now let's define each variable. A is actually our base. B will be our result. And X will be our power. These are the three terms. So let's go back to our power expression real quick, which we established to be 2 to the power of 2. Actually, let's make that 3 so we get 3 different numbers. 2 to the power of 3 is 8 because it's 2 times 2 times 2. This is the base. This is our power. And this is our result. So now that we have these three terms, we can actually just convert it into this form, base, result, power, because we have all three, right? So this expression right here, 2 to the power of 3 equals 8, can be rewritten into log form by writing log A. A is our base, so we know it's 2. B right here is our result. 8 equals our power, which will be, in this case, 3. So this equation right here, 2 to the power of 3 equals 8, means the same thing as log base 2, 8 equals 3. Now what you need to pay attention to here is that the equations do not actually equal to each other, because this one up here equals to 8 and this one equals to 3. But this log base 2 8 equals 3 is just a different way of expressing this base power and result relationship. And what I just wrote down earlier is basically this right here, which will be in your formula booklet as well. And as you can see, this does not mean equal, it just means two different ways of expressing the same relationship. Now, these domains, we just have to learn them for now. We just need to remember that the base and the results cannot be 0 or less than 0. And also, why cannot A equal to 1? Well, if we look at it from this expression right here, 1 to the power of x equals, let's say, b would be 4, right? This equation doesn't make sense, because we cannot possibly find an x value for which 1 to the power of x will be equal to 4, because 1 to the power of any number is 1. Okay, so now let's do some practice questions. Write down the value of log base 3 27. So first we need to understand what it's asking for. It's asking us to write down the value of log base 3 27, which means this must be equal to some value which we want to find, right? And now we have an equation. And we can rewrite this equation into the form of a to the power of x equals b. Now we know 3 is the base, so it must be 3 to the power of x, because x is power, and we know this number here is the result, 27. So 3 to the power of x equals 27. So right now we'll start by solving it intuitively. 3 to the power of something equals 27. We just need to know that 3 times 3 times 3 is 27. Okay? Because 3 times 3 is 9, 9 times 3 is 27. Or in other words, 3 cubed. So x of a1 will be 3. a2. Log base 8 of 1/8 is equal to... Okay, so let's write this down again. So 8 is the base. And now we need a power, which we don't know, so we'll label it x. And this is what we want to find, because this log expression here will be equal to a power. So 8 raised to the power of x will be equal to our result, and the result is 1/8. So what number do we need to raise 8 to equal 1 on 8? Well, if we're familiar with our indices laws, we know if we raise a number to -1, we will get the reciprocal of the number. Reciprocal just means from 8 it will turn into 1 on 8. So 8 of -1 will be 1 on 8. Therefore, x is -1, and this whole expression here is also equal to -1. a3, log base 16 of 4 is equal to... First, let's identify the base. 16 to the power of some number, let's label it x, will be equal to the result, which is 4. In this case, 16 to the power of what will be equal to 4? Well, we see a relationship here. 4 to the power of 2 will be 16. In other words, 4 squared is 16. So how we can rewrite this equation is we can take the square root of both sides, and we'll find that 16, the square root of 16, will be equal to 4. Or you can just figure this out without looking at the first part as well. But whichever way you take, we will get to this equation here where the square root of 16 is 4. And another way of writing the square root of a number is by using the power of a half. 16 to the power of a half equals to 4. And in this case, x will therefore be a half. So therefore, the power will be 1/2. So if we raise 16 to the power of a half, it will equal 4. Part B, hence solve this equation. Log base 3 of 27, we solve that, it's 3. Log base 8 of 1 on 8, we solve that, it's 1. Minus log base 16 of 4, which is a half. Okay, equals to log 4x. And in this case, we want to solve for x. So let's simplify the left-hand side. 3 minus 1 is 2. 2 minus a half equals 1.5. So 1.5 equals to log 4x. Now we can rewrite 1.5 as 3 on 2 equals log 4x. So now we need to solve for x. Again, we need to identify the three terms. This is the base. This is our power. And this number right here, it will be our result. Okay, this is our result. So if we rewrite this whole expression into this form, we might be able to find what x is. Base is 4, power is 3 on 2 equals our result. Meaning, in order to find x, we need to raise 4 to the power of 3 on 2. Now, how we can solve this fractional power is by breaking it into two parts. What we need to realize is 3 on 2 can be broken into a half multiplied by 3. And a half is basically the square root. So the square root of 4 to the power of 3 will be x. So this can be rewritten into this. Or if you want to write only numbers, it can also be rewritten into this. Either way, both of these are the same thing. Now, the square root of 4 is 2. So 2 to the power of 3 equals x. And we know 2 to the power of 3 is just 2 times 2 times 2, which is 8. So therefore, for part B, x is equal to 8. Now, the last thing that we need to note in this syllabus statement is this expression right here, this equation, log base ex is equal to ln x. And e right here, this is actually Euler's number, which is approximately equal to 2.71828, blah, 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 blah. And it's an infinite numerical constant, meaning it has infinite decimal places and it never recurs. So we don't need to know too much depth about Euler's number just yet. We'll go over it in more depth in future videos. But for now, all we need to know is Euler's number is basically a numerical constant like pi. So in terms of this expression, log base e of x is equal to ln x. And ln basically stands for natural log. And natural log, it's almost like the original log expression. This is what log is all about. So the reason why there is no e here is because natural log just means log base e. If you see ln, that means log base e.